Okay, we're moving on to page 472 today. More trig. So the first set says the terminal side of angle theta in standard position passes through the indicated points. Calculate the values of the 6 trigonometric functions for angle theta. So let's do one of the odds or evens. So the point 8, 4. Standard position starts with 0 degrees over here, and we want to create an angle with the x-axis, and the terminal side of the angle passes through 8, 4. So 8, 4 would be right here. So that is our terminal side, and then reference angles are always, standard position angles are always based off of this 0 degree here. Okay. Well, that gives us a right triangle where the bottom is 8 and the side is 4. So we need to calculate the hypotenuse. 8 squared plus 4 squared. That's 64 plus 16 equals 80. And we take the square root of 80. Does 80 have any perfect squares in it? Is 80 divisible by any perfect squares? Like 4, 9, 16, 25, just 4. So the fast way to simplify this, if I take the square root of 80, that's actually 4 times, oh, it has 2 4s in it. No. Yeah, it does. Sorry, 16. So 16 times 5. So I can take the square root of 16, but I can't take the square root of 5. So the answer is 4 root 5. That's one way to simplify square roots, is to find any perfect square inside it and take the square root of that piece and then have the leftover. You guys are probably more used to saying 10, 8, 5, 2, 2, 2, 2. Now what do I do? Circle all the pairs. So I bring out a 2 times a 2, which is 4, and I leave in the square root of 5. Why does that work? That works because, you okay? So that works because 2 times 2 times 2 times 2 is 16. And 16 is a perfect square. So I'm taking the square root of 16 and the square root of 5, and it simplifies down to 4 root 5. Does that make sense? Now, the question says, find the value of the 6 trigonometric functions. So the sine, let's do this. The sine of theta is 4 over 4 root 5. Opposite over hypotenuse. The 4's cancel, and I'm not allowed to leave root 5 in the denominator. So I multiply by root 5 over root 5, and I get root 5 over 5. That is the value of the sine. Cosine of theta is going to be 8 over 4 root 5. So 4 goes into 8 twice, and then I have to rationalize, and I get 2 root 5 over 5. Okay. The tangent of theta is simply going to be 4 over 8, which is 1/2. Okay. And then let's do the cosecant. The cosecant is the inverse, not the inverse, the reciprocal of the sine. So it's 4 root 5 over 4, and the 4's cancel, and it's just root 5. The secant is the reciprocal of the cosine. So that is 4 root 5 over, that's a 5, over 8, which is root 5 over 2. And then the cotangent of theta is just the reciprocal of 1/2, which is 2. Everybody all right with those? Okay, let's put an angle in a different quadrant. So let's say we had -6 comma the square root of 5. What quadrant does that lie in? -6 comma root 5. Which quadrant is that? 2. So -6 on the x-axis and the square root of 5 on the y-axis. So here is our angle theta. But we build our triangle in that quadrant connected to the x-axis. So this is the triangle. So the x-axis value is -6 and the y-axis value is the square root of 5. So 6 squared plus the square root of 5 squared is c squared. That's 36 plus 5 equals c squared. So c is the square root of 41. Does that make sense? And then you would just do the same thing you did before. You do sine, cosine, tangent, and then cosecant, secant, and cotangent. The only tricky one would be the sine and the cosecant. So that's the square root of 5 over the square root of 41. I'm not allowed to leave square roots in the denominator. So I multiply by the square root of 41 over the square root of 41. And the bottom just becomes 41. And the top becomes 5 times 41, which is 205. The square root of 205. And you would normally need to check to see if the square root of 205 simplifies. But 41 is prime, so the square root of 41 doesn't simplify. So this is just 5 times 41, and there are no pairs in there. So it doesn't simplify. So that would be the sine. Okay? You guys all right with those? Okay. So the next set says, indicate the quadrant in which the terminal side of theta must lie in order for the information to be true. So number 16 says the cosine of theta is negative and the sine of theta is positive. So which quadrant is the cosine negative and the sine positive? Well, we need to remember that the cosine of theta is the x value on the unit circle, and the sine of theta is the y value on the unit circle. And one thing that we can do to remember this is a little mnemonic. ASTC. In quadrant 1, all of the trig ratios are positive. In quadrant 2, only the sine and then its reciprocal value, the cosecant, would be positive. In 3, the tangent and the cotangent are positive. And in 4, the cosine and the secant are positive. And the way I was taught was all students take calculus. But I think it's a lot more fun to say all suckers take calculus. I'm a sucker. You guys will be suckers. So, to answer this question, where is the cosine negative and the sine positive? Would be quadrant 2. Quadrant 2 has cosine negative and sine positive. Okay, so 24 says, where is the cotangent positive and the cosecant positive? That only happens in 1. Yep. Okay, what about the secant is positive and the tangent is negative? What quadrant would that be in? Well, the tangent is positive in 1 and 3, and the secant is positive in 1, and secant matches up with cosine, so it'd be 1 and 4, so it'd have to be quadrant 3. Okay. We good with those? Do you need to see another one? Uh-oh. You stuck? Let's do another one. Okay. Where is the secant negative and the sine is positive? Well, secant matches up with cosine, and the cosine is positive in 1 and 4. Or sorry, I want negative. So the secant is negative in 2 and 3, and the sine is positive in 1 and 2, so it would have to be 2. That fits both characteristics. What about where is the sine negative and the cosine negative? Where are the sine and the cosine both negative? Would be in 3. Yep. Sine is negative in those two. Cosine is negative in these two. So 3 is the only one that satisfies both. I wonder if there's a... Oh, that's pretty slick. Yes, I'm sure. All right. Look at number 26. If the tangent of theta is negative 5 over 12, and the terminal side of theta is in quadrant 2, what is the cosine of theta? Now there's a lot going on here. Okay, we know the value of tangent. We know where the angle is relatively. We know which quadrant it lands in. We want to know what the sine of that same angle is. So first, I'm going to draw theta. And I'm somewhere in quadrant 2. It doesn't really matter where it lands in quadrant 2. Now I build my right triangle. So here is my triangle. This is my reference angle. And the tangent is O over A. But that negative is actually kind of out front. So I know that 5 has to be the opposite side, and 12 has to be the adjacent side, but I have to be careful about where I put the negative. The negative has to go on the 12. Why? Because I'm to the left. And in quadrant 2, the x values are negative and the y values are positive. Okay? So I can use the Pythagorean theorem to figure out what the hypotenuse is. So 5 squared plus 12 squared equals c squared. So that's 25 plus 144 is 169 equals c squared. The square root of 169 is 13. Now I have the triangle finished. I go and calculate what is the cosine of theta. Well, the cosine of theta is going to be... oops. Where's my back button? Cosine is adjacent. So adjacent over hypotenuse. The answer is negative 12 over 13. Okay, let's try another one. Let's do the cosine of theta is negative 6 over 10, and we're in quadrant 3. What is the cotangent of theta? So I draw my theta, which lands in quadrant 3, and then I have to build my triangle using the reference angle, And that every reference angle triangle always connects to the x-axis. So cosine is a over h. So a is 6 and h is 10. Where does the negative go? Has to go with the 6. Okay? Can a hypotenuse be negative? No. Hypotenuse is always positive. The only reason, if you had a triangle, every side of a triangle is a positive length, right? The only time you run into negative lengths is when you're graphing triangles in the coordinate plane and you end up in quadrants 2, 3, or 4. Okay? So really, the length of the adjacent side is 6, but because we're in quadrant 3, we count it as a negative 6, but hypotenuse will always be positive every time. So now I need to find the length of the opposite side. So 6 squared plus 10, plus b squared equals 10 squared. So 36 plus b squared equals 100 minus 36. I get b squared is 64. Take the square root and I get b equals 8. But it's actually, it's not 8, it's negative 8 because I'm in quadrant 3 and all y values are negative in quadrant 3. So you do have to be a little bit careful with that. So now I want the cotangent of theta. Cotangent is a over o. So it would be negative 8 over 6, which simplifies down to be 4/3. Can you handle that? Okay, get to work.